At 14:30 hours, Ukrainian operators launched what should have been a routine strike mission. Within minutes, everything would explode literally. Their Shark D reconnaissance drone was circling above a damaged bridge. It was the perfect choke point. A Russian convoy moved below, towing a 152mm howitzer. An easy target, right? Except the drone wasn't hunting anymore. It was being hunted. Every time the drone transmitted video back to its operators, it was basically shouting into the electromagnetic spectrum, "Here I am." And the Russians, they had something listening. The convoy was moving toward the bridge at 15 kilometers per hour. The Ukrainian strike team was 4 kilometers away, but between them and the convoy were 3 layers of Russian defenses. Defenses that had already stopped more than 30 Ukrainian drones. The system watching for them, the Zoopark-1 counter-battery radar, wasn't originally designed to hunt drones. It was built to track artillery shells, calculate where they came from, and guide counterfire. But the Russians adapted it. They realized drone control signals are just radio waves, and radio waves can be tracked. Here's how it works. Zoopark detects the signal and takes a bearing. It draws an invisible line from the radar to the source. One line isn't enough to pinpoint you, but several lines from different positions will intersect at a single location, your location. 3 minutes later, artillery starts falling on your head. The Ukrainian operators knew the odds. If you transmit from the same spot for more than 5 minutes, there's a 40% chance you never transmit again. The Russians even had a name for it: counter reconnaissance by fire. No visual needed, just detect, calculate, obliterate. So, the Ukrainians adapted. They adapted fast. They were frequency hopping across 128 channels every second, never staying long enough on one frequency for Zoopark to lock on. Their transmissions were short bursts, 0.3 seconds of data, followed by 30 seconds of silence. Enough to fly the drone. Not enough to get tracked. Then things got worse. Thermal sensors picked up a Russian Orlan 10 drone approaching from the north. That meant Russian forces suspected operators were nearby and had launched their hunter. The Orlan's thermal camera could detect human body heat from 2 kilometers away. The Ukrainian team had to choose: keep visual control of the target, or hide under thermal blankets and lose the feed. They chose to hide. But before disappearing, they needed to warn the strike team 4 kilometers away. Standard procedure would require a radio handoff sending coordinates, vectors, timing, but that meant both teams transmitting at once, doubling the electromagnetic signature. They might as well paint a target over their heads. Instead, they did something ingenious. The Shark drone dropped a digital breadcrumb, a tiny encrypted packet on 433 megahertz, a frequency the Russians weren't monitoring. It contained GPS coordinates, convoy speed, wind conditions, and the optimal attack vector. Transmission time, 0.3 seconds. Too short to triangulate, too encrypted to decode, on the wrong frequency to even notice. The strike team received it. The convoy was halfway to the bridge, moving slowly through wreckage. They had about 10 minutes before it cleared the choke point. But between them and the target were still 3 layers of Russian defenses, the same defenses that had already neutralized more than 30 Ukrainian drones. At 14:45 hours, the FPV operator powered up his attack drone, a 7-inch carbon fiber frame, a 2-kilogram shaped charge, a 16.8-volt battery, enough for 7 minutes of flight. The target was only 4 minutes away. Should be simple, right? Wrong. The Russians had learned something critical about drone warfare. You don't need to shoot drones down. You only need to cut the link between drone and pilot. No link means no control. No control means a crash or a drone that flies home. Either way, the mission fails. For the first 2 kilometers, everything was smooth. The drone skimmed along at 3 meters altitude, hiding behind tree lines and ruins. The video feed was crystal clear 1080p at 60 frames per second. Then, exactly 2 kilometers from the target, the video began breaking up. Static lines. The frame rate dropped 60, 30, 15. The Russian Repellent 1 jammer had activated. A jammer like this is essentially a microwave oven with the door open, except Instead of heating leftovers, it saturates the air with electromagnetic noise. 400 watts of raw disruption. At 2 kilometers, the signal density was still 25 watts per square meter. The drone's transmitter output, 25 milliwatts. That's like whispering in a hurricane. The operator switched frequencies, dropping to 433 megahertz outside the jammer's primary band. The feed returned grainy, delayed, but usable. Video quality now looked like a 2005 flip phone, 10 frames per second. But it was something. At 1.5 kilometers, even this backup frequency began failing. The Russians weren't using a single jammer, they had layers of them. Pressure jammers on vehicles, portable trench jammers every 200 meters, and likely a Pole 21 area denial system behind the lines. 3 systems, overlapping frequencies, an electronic black hole. But unlike a real black hole, the Ukrainians had an escape. The drone had an artificial intelligence module trained on 10,000 hours of combat footage. It could identify vehicles, lock onto targets, and guide itself autonomously. But it needed 2 full seconds of clear visuals to lock on, and it could only lock from within 400 meters. That meant the drone needed to fly another 400 meters blind through the jamming to even try acquiring the target. The operator calculated, last known position plus convoy speed multiplied by elapsed time, the truck should be at the center of the bridge. He switched to dead reckoning. No video, just instruments. Compass bearing 073 degrees. Altitude 3 meters. Speed 45 kilometers per hour reduced to save power. Then, at 3.2 kilometers, something miraculous happened. For one single video frame 1/60th of a second, the image flickered in. The bridge was about 800 meters ahead. The truck was exactly where it should be, grinding across a twisted beam. The feed vanished again, but one frame was enough. He was on track. Another 400 meters of blind flight, and the artificial intelligence could take over if the drone survived that far. At 3 kilometers, the feed returned briefly crystal clear for a few seconds at a time. A gap in the jamming. Maybe Repellent 1 was rotating its antenna. Maybe bridge metal caused interference. It didn't matter. What mattered was what appeared in that brief window. A Russian interceptor drone, 20 meters up, already diving. Steep angle 45 degrees like a falcon hunting a pigeon. Both drones were nearly identical. 7-inch frames, 4 motors, top speed around 140 kilometers per hour. But the interceptor had the advantages. Altitude equals energy, and energy equals control. Drone combat is brutally fast. Closing speed, 280 kilometers per hour. Separation, 300 meters. Time to impact, less than 4 seconds. The Ukrainian operator had that long to save the mission. The Russian interceptor had another advantage, no warhead. The Ukrainian drone carried a 2-kilogram shaped charge. In aerial combat, that's like boxing with a backpack full of rocks. Every maneuver cost battery, speed, and stability. The Ukrainian FPV banked hard left, hitting its maximum turn angle. The frame groaned under 5 Gs. Motors strained left side at 40%, right side at full throttle. At 140 kilometers per hour, the turn radius was 89 meters. The Russian drone overshot and had to reposition. Energy management became the battle. Hard turns drained the battery 3 times faster. The Ukrainian drone's voltage was falling 15.2 to 14.8 volts in 10 seconds. At this rate, the battery wouldn't last to the target. The Russian pilot switched tactics. Instead of chasing, he climbed higher, gaining potential energy for another dive. The Ukrainian drone couldn't follow too heavy, battery too low. So the Ukrainian operator did something drastic. He cut throttle completely. The drone dropped from 15 meters to 3 meters in 2 seconds. The Russian interceptor dove straight into empty space where the drone should have been. But free fall has consequences. With no thrust, the drone became a brick. For 2 seconds, it had no control authority. The operator eased throttle back too fast, and the drone would flip. Too slow, and it would hit the ground. He applied 30% enough to stabilize at 3 meters. The drone wobbled violently, as the flight controller recovered from the near stall. Both drones were now low, slow, and draining battery. They spiraled around each other like boxers hunting for an opening. The Russian drone had better power to weight ratio, no warhead. It could climb faster, accelerate quicker, and pull 6 Gs, while the Ukrainian drone maxed out at 4.5. Each maneuver brought the Russian drone closer to the Ukrainian drone's blind spot. The Ukrainian operator had one move left, a maneuver they trained for but rarely used: a vertical reversal. He hit full throttle. The drone climbed at 10 meters per second, bleeding speed for altitude. The interceptor followed but didn't expect the next part. At the top of the climb, the Ukrainian drone nearly stopped mid-air. The operator cut throttle and slammed full yaw. The drone spun 180 degrees in less than a second, now pointed straight down the interceptor's throat. A head-on collision was imminent. The Russian operator committed. That was his mission. But at the last moment, the Ukrainian operator rolled hard right and dove. The Russian drone missed by meters. By the time the Russian pilot recovered, the Ukrainian drone was already at 5 meters altitude, racing for the bridge. The whole fight had lasted 18 seconds. 30% battery gone. Only 8% left. Voltage at 14.5 volts. The truck was 3/4 across the bridge. 3 Russian soldiers waited. Weapons raised, they had heard everything. At 14:49 hours, the drone entered their line of fire. The rifleman shot first. His AK-74 fired 650 rounds per minute. From 50 meters away, the bullets arrived in 0.05 seconds, essentially instant. One round hit. A 5.45mm bullet ripped through the carbon fiber frame and severed the rear left motor's power lead. The drone lurched. 3 motors meant 25% less thrust. It drifted left uncontrollably. At 35 meters, the first shotgunner fired his Saiga 12. 65 pellets spread into a 15-meter cloud. The drone, moving at 140 kilometers per hour, crossed it in under half a second. Most pellets missed. 2 didn't. One destroyed the right front motor. Another pierced the battery. Voltage fell. 14.5, 13.8, 13.2 volts in 2 seconds. 2 motors dead. Speed down to 80 kilometers per hour. Altitude falling. At 20 meters, the second shotgunner fired, but the drone unexpectedly dropped 2 meters, and the buckshot missed overhead. 15 meters. The third soldier, guarding the truck cab, couldn't lower his weapon enough. The drone flew at 1.5 meters below his angle. He stepped back, tripped over debris. 10 meters. The artificial intelligence made its final calculation. The operator wanted the cab to detonate the ammunition and destroy the entire crossing. Battery, 12.8 volts. Thrust, 40% and falling. Distance, 5 meters. Proximity sensor, armed. Impact came at 14:49 hours and 47 seconds. The drone hit at 62 kilometers per hour, slow but sufficient. The copper jet punched into the ammunition compartment. 8 152mm shells detonated at once. The blast hurled the truck 2 meters into the air. The bridge deck cracked. The truck and howitzer fell into the river. Above them, the Shark D drone recorded everything. Smoke rose 200 meters. The nearest alternate bridge was 15 kilometers away. This is modern warfare. Every moment watched. Every mistake punished. Every battlefield has a pilot waiting with a 7-inch drone. Bye for now.